Now it's time to learn Chapter 7 on applications of definite integrals. One of the most obvious applications of definite integrals is to find areas in a plane. You can find area between curves, which is simply the integral of the upper curve minus the lower curve. You can also find the area enclosed by intersecting curves. This is essentially the same as area between curves, except the limits of integration are given by the x-coordinates of the points of intersection. Another important application of definite integrals is to find volumes. You can find the volumes of revolved solids, which would be a graph that has been revolved around an axis to form a solid. Or you can find the volume growing out of a plane. But common to both is the idea that a volume is the integral of area. Alright. The basis of the washer method is that the cross-sections of the revolved solids often look like washers or donuts, which is the same as two concentric circles of different radii. To find the area of these donuts or washers, you can use the formula given here. The uppercase r is the larger radius, which is equal to the value of the function that forms the outer edge of the solid, and the lowercase r is the smaller radius, which is the value of the function that forms the inner edge of the solid.
So as Johnny was saying, you can see right here that you take one portion of the curve, and as you rotate it around, you make a solid that is a circular disc, and the equation is basically the area of the base times the delta x, which is the length of the x. And as you know from previous work, that you always make x go towards infinity, or delta x go towards infinity, and this makes the length really small, and eventually you can add up the little slabs of circular discs together to get the total volume. And here you can just see that adding the sigma is adding up all the volumes together. Okay, so the next method is called the cylindrical shell method, and this method is used to integrate a curve based on the perpendicular axis to it. So if the curve is y equals f of x, instead of rotating around the x-axis as you did in the previous method, you rotate it around the y-axis. And as you can see, the radius, or delta r, is very symbolic of delta x in the previous method, because the radius stays the same, the distance between the two radii, and the thing that changes in this one is the height. The height is based on the function f of x, and you can plug this into the equation that will be coming up soon. So what you want to be careful of is you want to make sure you always integrate to the perpendicular axis, and when it's tilted so the curve is on the x equals f of y, you don't make the mistake of doing the same sided axis or the parallel axis. And as you can see here, that it's basically doing the volume is the integral of area formula to find and add the different cylinders that are formed as you rotate around the curve. And once you add all of these up and the limit approaches infinity for the distance between each radius, you get the volume that you're looking for, and the solid is formed. The last section of this chapter is based on the cross-sectional area that comes out of a plane. So basically you're finding the shape that comes out of a certain f of x formula, and you add up the cross-sections as you go from point A to point B, and once you take the integral of this, you find the volume. So here the cross-sections are always the same shape, so if you're trying to solve for the square, keep it a square for the entire area. And to find the length of the square, you basically just take f of x, but here you just have to be careful and multiply it by 2 because it goes both in the plus and minus y direction, so the length would be 2f of x. And to find the cross-section of a square, it's s squared, so it would be 4f of x squared. And once you find out the cross-sections, you take the integral, and yeah, these problems are fairly simple, and they can become fairly tedious, but it's better to have these on the AP test because they're very easy. So that's it for chapters 6 and 7, and I hope you guys are prepared well for the test. And you should know the broad concepts, but you should definitely practice many problems before taking the AP test so you know the various tricks they have. And our group just wants to thank you for watching the video, and I hope you enjoyed it.